So let's talk about exponents in order of operations. All right, now before we get started, you guys, just keep in mind, okay, that math is just forcing things to be what we want them to be. So if you can just learn to manipulate math statements, it may not look like what you expect, but if it looks like something you want, then it doesn't matter what you expect, okay, as long as it maintains equivalency. So as long as it has the same value. So let's go to one of the old-fashioned ones, right? Like 1 plus 1 equals 2. Now, this looks pretty normal. This looks like what we're used to. But if I changed it, let's say instead of a 2, for some reason, right? Let's say I went into the 2 and I said, I don't want a 2 there. Now, I need something that has the same value as 2, though. So if I change that to something like, I don't know, 10 minus 8, see how that still has the same value? But the full statement of 1 plus 1 equals 10 minus 8 is still true. Now, again, I'm not completely sure why you'd want to do that right now, but again, I'm just showing you that changing things to be what you want them to be is very, very useful in math. And if you can do that, if you can learn to do that, to change things into equivalent things that look different, you can go a long ways in math, okay? So even like the 1, right? Let's say that instead of 1, I wanted it to look like something else. Like, I don't know, 3 divided by 3. That has a value of 1. All of this is equal. We didn't change any of the value overall of things. What we did change is the way that it looks. So another thing to keep in mind with math is that it's going to take, it's going to give us strategies to take big problems and break them down into smaller, more manageable problems, targeted problems, okay? So when we see big problems, and that's what the order of operations is, we're going to learn, it's going to take really big problems and force us to focus on smaller, more manageable problems. All right, so this is called an exponential expression, okay? Yeah, let me erase that garbage. There's 2 parts to an exponential expression. The first is the 5 there, which is called the base. And then the 4 up here, this is called the actual exponent, okay? Now, some people, they don't like the word exponent. I don't really know why. I don't know what its roots are or anything like that. But people hate the word exponent. They would rather call it, and yes, it does sound a little bit more attractive when we say power, right? Like it's 5 to the power of 4. I don't know. Maybe I just like to use the word power. But in any case, an exponent or power, it is the same thing. But the base is always the base. This is vocabulary that you guys are going to want to get used to. And yes, and unfortunately this happens from time to time, but I do interchange exponent and power from time to time when we see exponents, okay? And you'll see some exponents in the homework, of course. We'll just be evaluating these really in this particular lesson. But when we see exponents, actually, let's go back. Let's go back a little bit. We're going to talk about this a little bit later on. But in the past, when math people, even if we went back as far as cavemen, I suppose, is they would say, well, look, you got, I don't know, I'm going to use cows. I like cows. I like to eat cows, actually. So we could say, you have 3 cows, right? And then I could say, well, I got 3 cows. And our neighbor has 3 cows. And their neighbor has 3 cows. Lots of cows, right? But everyone has 3 cows. And if this happened enough times where everyone had the same number of cows, it'd be like, dude, I'm tired of adding 3 all the time and showing that I'm adding 3 all the time. Well, what did they do? They said, we're going to simplify this into what is called multiplication, right? And this would say that we'd have, well, we got 5 groups of 3. 5 times 3. And they were like, wow, that was really fast. We were able to simplify 3 plus 3 plus 3 plus 3 lots of times really fast. Well, it came to a point where they were like, well, they were doing multiplication quite often, and it was repeating as well. So you could say, well, I got 7 groups of 7, groups of 7, groups of 7. I don't know the context for this, but I suppose it happened at some point. And they're like, look at all these 7s that I had to write. And one thing that math people that you'll learn, and this is true with pretty much all math people that I know, is that they're pretty lazy, actually. They don't like to write all this stuff. And one of the worst things you can see in life is a grumpy math person. And they're like, if I have to write all these 7s another time, I'm going to go nuts. So math people were like, we got to find a way to simplify this, just like we did with addition. And that's where exponents came into place. So they said, look, what number are we multiplying together all the time? 7 in this case, right? And then they said, well, how many 7s are there? And they counted 1, 2, 3, 4, 5, 6 7s multiplied together, and that is what they call an exponent, okay? So this expression at the top there, 5 to the power of 4, it could also be written, and again, this is part of that manipulation bit that I was talking about. It could be written as 5 times 5 times 5 times 5. I think that was 4 5s. So, again, it's a matter of writing it in a way that you want to see it. And, of course, you could evaluate it at that point. But we'll look at that in more detail here in a second. All right, so when I solve exponential expressions like this, well, I usually use a calculator, but I can't use calculators yet. So I would expand this out. Okay, so instead of 3 to the power 4, I would want to see the repeated multiplication. 3 times 3 times 3 times 3, and then working from left to right, 3 times 3 is 9, times this 3, 9 times 3 is 27, and 27 times 3 is 81. So that is the value of 3 to the power of 4. So here's our next question. It says, write 7, I guess I use 7s, but that's okay, we can use it again. 7 times 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 7. I think that was all the 7s. In exponential notation, all right? So take 15 seconds and just see if you can write this as an exponential expression or notation, okay? Now in this problem, we know the base is 7 because it's the number that's being multiplied by itself over and over and over. The question is, how many 7s are being multiplied together? Let's count them. 1, let's see if I can get this to mark. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the power or exponent of the base 7 is 11. And this would be that math expression written in exponential notation. Now let's talk about the order of operations. 4 steps in the order of operations. Now, some people are like, there are 6 steps to the order of operations. That is not true. There's really only 4. I mean, there's 6 operations, right? You got parentheses, exponents, multiplication, division, addition, subtraction. Now, in the past, usually in elementary, teachers are like, look at your order of operations. Look at this awesome acronym that it creates, PEMDAS. And then in your brains, you start thinking everything is PEMDAS, right? Especially when it comes to math. But the truth is that it is not always PEMDAS. Sometimes it is, but it's not always. So parentheses, let's talk about parentheses real quick. Parentheses, I mean, you know, just regular parentheses like that. Hopefully my handwriting is not too bad. We'll see parentheses look like this as well, which we'll talk about in the future. Actually, probably today, actually. You'll see sometimes parentheses like this, but there's a point in math where these symbols, the brackets there, become a different meaning, okay? Now, we just looked at exponents, but step 3 right here, multiplication or division, again, it's not always multiplication first. It could be division, depending on which one comes first, left to right. So in other words, in a division and multiplication problem, let's just use those two just to look at an example.
Okay, don't get mad. I kind of look.
So multiplication and division, we got the 3. Let's say that it was 3. Oh, you know what? I'm going to make it 33 just for convenience purposes, right? Divided by 3 times, I don't know, let me think. Well, yeah, that should work. 11. All right, if I saw 33 divided by 3 times 11, now, because of PEMDAS, the worst thing you could do on this one is to do 3 times 11 first. And see that little V right there in red? That's how I'm going to show my work for this one. 3 times 11, I know, is 33, right? Again, I'm showing you what not to do. And the reason why we wouldn't want to do this, this multiplication first, is because it's multiplication or division from left to right. So we need to notice, and the final answer to that would have been 1, which would have been great. But we have to do the division first. You have to do the 33 divided by 3 first, because it's farther to the left, which would be 11 right there. So 11 times 11 now, right? Bring down that 11. Bam, you get 121, which is a very different answer than if we did the multiplication first. And if you do the multiplication on a problem like this first, it's out of order. It has to be from left to right. Now, the same thing works for addition and subtraction. Sometimes you'll do a subtraction first because it's farther to the left. It's not always PEMDAS. Sometimes it's PEDMAS or PEDMSVA, something like that. I don't know. So the order of operations is crucial because if for some reason, and this happens often, where people do the order of operations out of order, it changes things dramatically. It's kind of like a surgeon, right? Like if a surgeon were to give you the anesthetic after they cut you open, that would be very, very, very bad, right? Like you want the anesthetic before you go and they go and cut you up, right? So it's the same thing with math. Is if you do things out of order, you've damaged and hurt the math problem very badly. We want you guys to be efficient and precise math surgeons. Why would we do the multiplication first? Yeah, so we have to do that multiplication first. 6 times 7 is 42. Now, one thing about, I know I just kind of made several assumptions on this assignment so far, but we do assume that you guys have your times tables memorized up to the 12 multiplication tables, okay? So like 12 times 12. If not, we'll use long multiplication to do it. But 6 times 7, we expect you to know, is 42. Now, rewriting this, 12 plus 42, right? Because we just did the multiplication. It is gone. It has a value of 42. And you guys can see that I'm manipulating this math sentence to be what I want it to be. And what I really want it to be is one individual value, okay? So now that we did the multiplication, I've only got one more operation left, and that's the addition. 12 plus 42, just as a quick reminder, right? You can add vertically like this, particularly because we're not using calculators. In the future, when we can use calculators, I would just say type that into your calculator. But since we're not using calculators yet, we'll add it vertically. So 2 plus 2 is 4 in the ones place. In the tens place, 1 plus 4 is 5. So the final answer, or the final evaluation value for this one, is 54. All right, now this is a good example because it's going to force us in the order of operations to do subtraction first, just like we've talked about. We must do 17 minus 12 first. So focusing on 17 minus 12, 17 minus 12 is going to give us 5 right there. So that would be 5 right there. Now writing the rest of the expression plus the 25. And when we combine these two together, we get 30. There it is. So again, the order of operation, it forced us to do the subtraction first and then the addition. If you did the addition first, you could have made a big error in finding your answer. And we do have a problem like this one. Simplify the expression 12 divided by 3 plus 9 minus 4 to the power of 2. Now, we're seeing some new things on this, especially with the exponent. But give this one a shot. We'll give you guys, 30 seconds? Maybe a minute. We'll see. All right, for this problem. So order of operations, right? First, parentheses. There's a set of parentheses, and 9 minus 4 is 5. So I rewrite the expression. But make sure it's simplified. And since we've evaluated the parentheses, let's look at the exponent, which is 5 to the power of 2. And again, I like to expand it. 5 times 5 is 25. So that takes care of the exponents. I'm looking for multiplication or division from left to right. I've got this division right here. 12 divided by 3 is 4. So now we've got 4 plus 25. And I've got to move now from multiplication or division to addition or subtraction from left to right. Of course, there's only the addition. 4 plus 25 is 29. And that is our final answer for this problem. The first thing that we're going to do on this problem, right, is, let's make this a little bit bigger, actually. And the first thing I noticed, there's actually 3 sets of parentheses on this one, right? And we're showing this in purple. You got the 8 and 4. They're in parentheses, but there's no operations on the inside of the parentheses. When you see parentheses, you want to start with the ones farthest on the outside. And we'll see another example like that in the next problem. But you're just going to start the order of operations on the inside of that set of parentheses. So I just want to focus on this big set of parentheses right there, okay? So I'm actually just going to zoom in on that again so we can just focus on that part. All right. So by the order of operations on this one, let's just look at the order of operations. We got parentheses. That's what we're looking at, the parentheses right here. There's no parentheses on the inside of the parentheses. So let's go to exponents. Bam. No exponents. So let's go to multiplication or division from left to right. And there's only this division right here, just like Matt showed. 72 divided by 8, right? Which is 9. Now the expression is 13 plus 9. See how we're manipulating this into smaller, more manageable problems. 13 plus 9. 13 plus 9 in the parentheses is 22. So I now have this set of parentheses. Let's zoom out so we can see the full problem. So this is what we have, but I need to write the rest of the problem. All right, so evaluating that set of parentheses brings it down to one individual value. And technically, now that it is simplified, since there's no other operations with it, I mean, you could say, well, I can get rid of those parentheses. We'll just keep them for now. But next, we did parentheses. I don't see exponents, so we're going to do multiplication. You guys need to get used to seeing multiplication like it is between the 8 and the 4. There is a multiplication symbol there, but remember I told you guys, math people are really lazy, so they don't even like to show the operations on that. Or at least with multiplication. So we're going to look at 8 times 4, which is 32. So we got that 32. Let's write the rest of the problem. 16 plus 32 minus the 22. I'm not going to use the parentheses now, because I don't really need it with the 22. And this is our new expression. We got addition and subtraction now from left to right, because I don't see any more multiplication or division. And we'll start with the 16 plus 32, which would be 48. So again, I'm just going to rewrite my expression as many times as I need to, just so I don't lose track of where I am. And now, 48 minus 22. Now it's good to see mistakes, because again, we should expect to make mistakes. So this is 26 plus 219. So again, I'll just show that real quick. 219 plus the 26. And this will be our final answer right there. Again, a 15. 1 plus 1 plus 2 is 4. There's the 245 right there. So, again, the final evaluation for this one is 245. So I finally got that correct. Now, again, I'm glad we can show this. You guys shouldn't expect me to get all the answers correct. Sometimes it'll be on purpose. This one, it wasn't on purpose, but it's okay. It kind of felt wrong. But it's good to see that we can correct those, okay? All right, so we got 3, and just like we had before, we got brackets, and we have parentheses inside those brackets. Now, the brackets do act as parentheses for this particular case. So again, all I'm really going to focus on right now is the set of parentheses on the inside of that set of parentheses, which I've outlined in purple here. And inside of that set of parentheses, I start the order of operations over. So there's no parentheses, there's no exponents, but I do have multiplication, right? 6 times 2 is 12. So now inside that set of parentheses, I got 12 minus 5. Moving on to addition or subtraction, there's only the subtraction right there, 12 minus 5, which is 7. Now, again, we'll show that in this set of parentheses, which is inside this set of brackets, and it would show as 7 plus 4 times that set of parentheses. Now, again, it's not showing the multiplication there, which should have shown right there between the 4 and 7 in parentheses. And I mean, even at this point, you could write the 3 in the front just to show that it's being multiplied, just so we can see the full expression. But in any case, we evaluated that set of parentheses, so we're going to move on now into this big set of brackets right there, right? And yeah, I don't really need this one as far to the right there. We can move it over. Just this may just read a little bit better, that's all. All right, so in that set of parentheses, we already evaluated the set of parentheses, so we look at exponents. There are none. And we see this multiplication here between the 4 and 7. 4 times 7 is 28. I don't see any division, so it's just that multiplication. And again, I'm just going to quickly rewrite the new expression. So we got 3, and in this set of bracket parentheses, 7 plus 28. And now 7 plus 28 is 35, which is shown in the brackets. But it's going to be multiplied by 3. Now this would read as 3 groups of 35, right? So I need to multiply these out. I got 35 times 3. Now you could have shown the 3 on top of the 35 with this vertical multiplication. It's really up to you guys. But the first place value, the ones, 3 times 5 is 15. Now that's 110. So I'm going to move it over, but I'm going to multiply the 3 and 3 first. 3 times 3 is 10, and then plus the 1 is, I said 10. I meant 9. 3 times 3 is 9, plus the 1 is 10. I was thinking ahead on that one. So 3 times 35 ends up being 105. Get through this first section. So we're going to simplify this one. We'll do this one together. And again, with the order of operations, first I'm going to look for parentheses. In this problem, there are none. There's no parentheses. That's better. But I do see the exponent right there. 3 to the power of 2. And I'm just going to expand that to show 3 times 3. It just may help us to think about that better. 3 times 3 is, bam, it's 9. Now again, I'm going to rewrite the expression. And it's 4 times 9. Which the multiplication can be shown in several ways. With that's one of the symbols it can use. Sometimes we'll just use a dot like we've shown right here. I just use the dot because it's easiest. Sometimes it's shown in parentheses, right? So we did the exponents. I don't see any other exponents. So I'm moving now from exponents into multiplication or division from left to right. And scanning this from left to right, I got the 6 plus 12. I see the division right here, which is farther to the left than the multiplication we just talked about. So I need to do that division first. 12 divided by 2 is 6. So again, rewriting this. All right, now that was the division part, but we also have that multiplication, so we need to take care of that also. 4 times 9 is 36. So again, rewriting this expression. So we got 6 plus 36, and we're just moving from left to right on this one because there's no more multiplication or division. In fact, there's no subtraction on this one. I only have addition left. So addition from left to right, 6 plus 6 is 12. And again, I'll just write the expression plus the 36. And so now I need to add the 12 plus 36. So I'm going to do that vertically. I know not everyone really needs to show the work for this one. I just I'm not feeling comfortable since I made that mistake. So 12 plus 36, I'm looking at the ones place. 2 plus 6 is 8. In the tens place, 1 plus 3 is 4. So the final evaluation for this one, 48.